In today's video, I'll be showing you the basics of the create mod, including how to create and move around rotational power and some of the basic items you'll be needing. So without further ado, let's get to building. Now the first thing I'm going to show you with the create mod is the fact that it adds a new ore called zinc. And this ore can pretty much be found anywhere iron can be found. And to mine it, it requires an iron pickaxe or better. And when you mine it, you get the item called raw zinc. And what you can do with this is take it over to a furnace and put it in the furnace and smelt it into a zinc ingot. And zinc can be used for quite a few things, but one of the main ones that Create Mod adds is called the copycat panel. And to make this copycat panel, all you have to do is put a zinc ingot in a stone cutter, and then you can get these copycat panels. And what makes these copycat panels so nice is that not only is it a panel that you can place facing on its side, or you can break it and make it face down, but if you right click on it with a block in your hand, it will take the texture of that block. And this can be done with any block you want. As long as it's a full block, you can place it down and then texture it like this. And if you wanted, you could even give it the texture of a crafting table, although you can't actually use it. And if you were to try to do a non-full block like a stone cutter or stairs, it would just place that block down rather than giving it the texture. And with zinc, you not only have the deep slate version of the ore, but if you come over to a crafting table and you put 9 raw zinc, you can get a block of raw zinc, and with 9 zinc ingots, you get a block of zinc. And the block of zinc looks like this, and the raw zinc looks like this. And all 3 of these still require an iron pickaxe to mine. And one of the most important create mod items is going to be this, which is the andesite alloy. And the reason this is so important is because it's so versatile and it can make different items, and those different items can make even more items. So it is a very useful thing to have, and it might even be more important than iron. And the way you craft them is you take 2 andesite and put them in the crafting table like this, and then with either 2 zinc nuggets like this, or you can do iron nuggets instead, and both of these recipes will get you the andesite alloy. And another really useful item that this andesite alloy can make is called the andesite casing, which is this block that I'm looking at here. And this andesite casing is used to make so many of the create mod machines. But for now, the main thing that you need to know is that andesite casings aren't actually craftable in a crafting table. You make them in a different way, which is actually by taking a stripped log and placing it down. And if you have an andesite alloy in your hand and you right click on that stripped log, it will turn it into andesite casings. And to pick up andesite casings, you need a wooden pickaxe or axe or better. And another very useful item with the create mod is the wrench. So basically what this does is if you look at any create mod item, then you crouch and right click, it will pick up that item and put it in your inventory. And there are a few exceptions for what it can pick up. For example, it can't pick up zinc ore or blocks of zinc or the raw zinc, but it is able to pick up copycat panels. So if you place down a copycat panel and you don't like it there, you can just pick it up. Or another thing you can do is say you put a texture of a block inside of the copycat panel, and then you decide you don't want that texture. If you just right click on the copycat panel with the wrench in your hand without crouching, then it will pick up the texture of that block and leave the copycat panel there, which leaves it free to place a different block inside. To craft the wrench, we use this recipe, which is placing 1 stick here, 1 cogwheel above the stick, and 3 golden sheets like this. And the final important item I'll be showing you is going to be the engineer's goggles. And these goggles, when worn on your head, will not only make you look more stylish, but also the goggles will allow you to see some stats about certain items whenever you look at them. And to craft the goggles, you place 2 any colored glass with a gold sheet in the middle and a string on top. and that will get you your goggles. And there are some items in the create mod where if you hover your cursor over them, you may be able to see that it says to hold a button for a summary of the item. And whenever you hold down that button, you get some information on that item. Now, the create mod is based around using rotational force to generate power. I'll show you what the basic items that generate rotational power are, as well as tell you what stress units are. So the first item here that will generate rotational power is called the hand crank. And what this does is if you right click on it, it will start spinning it counterclockwise. Doing this will also take down your hunger. As you can see, my hunger is going down pretty fast. And one of the basic ways to move stress units around is called the shaft. So you can place it down anywhere you want, and this works only on some items, but with the wrench, you can actually right click on a side of the shaft, and it will rotate on that axis. So if you have it like this and you want it to be vertical, you can right click on this side with the wrench in your hand and it will become vertical. But say you have it facing this direction and you want it to face this direction, well, if you right click on the top, it will do just that. And if we put the hand crank on this, you can see that there's a little part here where the hand crank actually has a shaft on it. And that part right there is where the rotation will output. So if we have our hand crank here and we have the shaft in front of it, it'll start spinning the shaft. But if we instead put the hand crank here, we can see that that part right there is not connected to the shaft. So whenever we spin it, it won't output power to this shaft. It'll only output whenever it's the correct direction. And the next thing that generates stress is going to be water wheels. So there are two different kinds of water wheels. The first one is the large water wheel, which is quite big and requires a 3x3 area to be placed down. So if I were to try to place the large water wheel on this block, it says that it needs to clear the blocks for placement. But if I move it up by one block and then try and place it, it will actually place it down. And similar to the hand crank, it has this little shaft looking spot here where you can place a shaft off of, and whenever this water wheel spins, so will the shaft. And there's also a smaller version of the water wheel, which has a similar thing here where you can place a shaft on it and it will output the rotation to there once it starts spinning. And to get a water wheel to actually spin, you may have guessed it already, but you basically have to place flowing water on the side. So as you can see here, we have the water flowing, and since the water is flowing this direction and then down, that means the large water wheel is going to spin clockwise, whereas the smaller water wheels that are on the opposite side of the water as the large water wheel is, they will actually spin counterclockwise since that's the way the water is flowing between them. One thing to note with these water wheels is that the water actually needs to be flowing for the water wheel to spin. So as you can see here, if I were to block off these two sides and just place a water source that isn't flowing, this water wheel is not gonna spin. Another thing to know about these water wheels is if you have an area like this where the water can flow all around the wheel, then no matter where you place the water wheel will actually never spin. And that's because the water flowing this direction and this direction cancels out the spin, since flowing this way would try to spin it clockwise, but the water flowing this way tries to spin it counterclockwise. And the same thing goes here, you have it trying to spin it counterclockwise, but since we also have water over here trying to spin it clockwise, it just cancels out the movement. And to fix this, all you would need to do is place literally a block anywhere, and it should start spinning. Since the water now has to flow around the water wheel in one direction rather than multiple. And it's also good to note that if you were to move the water here, you're still going to have the same problem as before. Even if you have this block here, what you would need to do is block the water off on the block next to it to get it spinning. Now this next item that generates stress units is actually going to be a windmill. And as you can see, this windmill can just spin and generate rotational power while doing it. And to make a windmill, you first have to place down what's called a windmill bearing. Then on the front of it, you can place any block you want. And directly connected to that block, you need to place what's called windmill sail frames. So what you can do is place them out like this. And it doesn't matter which direction they're facing as long as they're directly attached to this block. But if we were to try to right click on this windmill bearing to start it up, you'll see that it says this contraption was unable to assemble, and that's because you need to have a minimum of 8 sail-like blocks to be able to have the windmill spin. There are 2 other sail-like blocks rather than just these windmill sails, and those are the windmill sail frame, which is just the windmill sail, but without that little wool covering on it. And the other sail-like block is actually any wool. And since we now have at least 8 sail-like blocks, we can go ahead and right-click on this bearing, and it will start spinning. And out the back of the windmill bearing here, you'll see that it has that same little texture as a shaft where you can place a shaft down on and it'll spin that shaft. And the last generator I'll show you is called the creative motor. And as you might have been able to tell by the name, it's only available in creative. On the front of the creative motor, it has this same texture as a shaft where you can place a shaft on and it'll start spinning that shaft. And what's good about this creative motor is that it doesn't require anything other than being placed down to spin a shaft. So unlike the water wheel, which needs water, or the hand crank, which needs you to manually crank it, this one just works without doing anything. And another thing is that you can see on the side here this little box, and if you hold right click down on it, you'll get this menu. And while you continue holding down right click, you can move this little bar across, and what these numbers mean is how fast the output of the rotation will be. So in the create mod, there is different levels of RPM, which is the speed that a shaft will spin at. So the different RPMs range from 1 RPM all the way up to 256. And on the left side of this bar here, you can see that there is 2 little indicators of which direction the rotation will be. So on this bottom row, it'll output the rotation counterclockwise, but if you go to the top row, it'll output it clockwise. And we can see here that if we set this to 256 RPM, this shaft will start spinning really fast. But if we want it to go really slow, we can set it down to 1 RPM. The default settings for a creative motor is 16 RPM counterclockwise, which is this. So now that you know the different ways to generate rotation, we'll need to put our goggles on for this next part. So with the goggles on, if you look at anything that can generate stress, it will have these generator stats on the right side of your screen. And what this is telling you is how many stress units, or SU for short, it's generating at the current speed that it's spinning. Since this hand crank is not spinning, it's generating no stress units. But if I were to start spinning it, you'll see that that number goes up to 256. And if I let go, it'll go back down to 0. And stress units in the create mod are what your machines use to be able to get powered. So along with having rotational speed, your machines will also take up a certain amount of stress units depending on how fast they go. And the faster your machine spins, the more stress units it will take to make that machine do its job. And if we go ahead and look here at the water wheels, we'll be able to notice 2 things. The first is that if we place shafts down on this, you'll see that this shaft on the large water wheel is actually spinning half the speed of the shaft on the water wheel. And that's because there's a trade-off between the large water wheel and the small one. And the trade-off is that the large water wheel generates 512 stress units, but only outputs 4 RPM, whereas the regular water wheel outputs 8 RPM but only 256 stress units. But there is actually a way to get the 512 stress units from this large water wheel and the 16 RPM from this small water wheel. And that is to take your large water wheel and place it down, give it some water to make it spin, and then on top of that large one you can place a small one, and then if you give the small one power as well, you'll see that this large water wheel is now spinning twice as fast since the shaft here is connected to the large water wheel shaft. And this brings me to my next point, which is that whenever you have two different generators spinning at different RPMs, as you can see, this one's at 256 RPM and this one's only at 16. Whenever we place the shafts, we can see that they're clearly spinning at different speeds, but whenever we combine the two into one shaft, it will spin at the speed of the fastest generator in the system. So this is still only set to 16 RPM, but since this one is 256 RPM and they're stuck together, that means this one's going to be spinning at 256. And whenever I remove it, this one spins back to the normal speed. And we can see that since the shaft on the large water wheel is connected to the one on the small one, the small water wheel is still spinning even without water. We can see that this large water wheel is spinning to generate 512 stress units, but in the generator stats for the small one, since it doesn't have any water flowing next to it, it's not actually generating any stress units. But if we change that and place water here, we'll see that it doubles the speed of the large water wheel, since we just learned that connecting two different RPMs will take the speed of the fastest RPM. And now this makes 256 stress units and this one makes 512. Since we're combining 512 stress units with 256 into the same shaft, that means that those two amounts of stress units are going to combine into a total amount of stress in the system. And in our case, since we have 256 stress units plus 512, that means our total output is 768 stress units. And there's also this item called the stressometer, which will tell you how many stress units are in a network. And we can see that it has this shaft on the side, and if we place that shaft on another one, we'll see that it starts spinning and it tells us the information on how much percentage of the stress we've used and how much we have remaining. And we can see that since we aren't using any stress and we have these two water wheels, they combine to make the 768 stress units. And there's also another similar looking item called the speedometer, which measures the speed that a shaft is spinning at. And if we place a speedometer on top of the stressometer, it'll say that it's spinning at 8 RPM, which is the speed that the regular water wheel spins at. And the more water wheels you add to this network, the more stress units you'll have, and the higher this number will be. And since you already have the one small water wheel for 8 RPM, you can just add more large water wheels to generate more stress. And no matter how many large water wheels you add, it will never slow down under 8 RPM since it's connected to this water wheel. And before we move on to how the windmill generates stress units, I'll show you how to craft the hand crank and water wheels. So first, to craft the hand crank, you just put 1 andesite alloy along with 3 of any kind of plank in this pattern here, or you could even move the andesite alloy to the opposite side of the crank. And using this recipe, you get 1 hand crank. And to make a water wheel, you place a shaft in the middle of the crafting grid that is surrounded by any kind of plank, and that will get you 1 water wheel. And to make the large water wheel, you have to put a regular water wheel in the middle of the grid and surround that in 8 more planks, and that will get you 1 large water wheel. So whenever you're making a windmill, each of these sail frames that you put on the windmill will give you 64 stress units, which means that since we have these 8 windmill sails on the outside and 1 white wool in the middle, since each of these generates 64 stress units, whenever we look at it, it should generate 576. but instead it says it's only generating 512. And that's because this windmill only generates stress units in increments of 512. So if we were to add enough windmill sail frames here to get us 1024 stress units, since that's a multiple of 512, we'll see that output. And if we have a bunch more frames, you'll see that it goes up to 2048, which is again a multiple of 512. And there is a maximum amount of stress that a windmill can make, which is 8,192 stress units, which is also a multiple of 512. And to get that many stress units, you would have to have 128 sail-like blocks. And to craft the windmill bearing, you just have to put any stone type block along with a wooden slab above and a shaft below, and that will get you your bearing. To make the windmill sails, you have to put any color of wool along with 2 sticks and an andesite alloy, and that'll get you 2 windmill sails. To make the frames, all you have to do is put that windmill sail in a crafting grid and it'll turn into a frame. And you can also do this the other way around by putting a windmill sail frame in the grid to make a windmill sail. Now that we know how to generate rotational power and stress units, the next thing I want to show you is some simple ways to move your stress units around. And the ways I'll be showing you how to move power around is the shaft, the cogwheel, the large cogwheel, the gearbox, the belt, and the encased chain drive. And shafts are pretty simple. Basically what they do is you can place it down and you can extend it as far as you want, but it can never turn without the help of some other items. And one of those items happens to be the gearbox. So basically what this gearbox does is whenever you place it down, you can have shafts going in from 4 different sides. And what will actually happen is if you have a shaft going in here that's spinning clockwise, it will actually output on this side counterclockwise. And we can demonstrate that here by spinning this hand crank counterclockwise, and you can see that on the opposite side it's outputting clockwise. And gearboxes are one of those items that you're able to rotate using the wrench. And if you rotate it on the side, it will become a vertical gearbox. And what this does is it's basically the same, except for its shafts are now 2 on the side and 2 going vertical. So you can place a shaft up here, and if you were to spin this hand crank, that vertical shaft will also spin. And with the wrench in your hand, if you right click on the top of a vertical gearbox, it'll change the direction that the side shafts are. So you can have it input or output from this side, but if you ever want to change it, you can just right click on it with the wrench, and doing this will no longer power it since there's no place for the shaft to connect on this side and this side. Unlike other things that can be rotated, like the shaft, whenever you make a gearbox like this vertical, it actually changes to a completely different item called the vertical gearbox. And you can see that whenever I picked it up, it didn't convert back to a normal gearbox. It became a vertical one. And we can do this the other way around by placing a vertical gearbox and making it into a normal one by rotating it. But as you can see, if we pick up a shaft, it's always going to be a shaft no matter which way it was rotated, since that's just how it works. And to craft a shaft, all you have to do is place andesite alloys with one above the other in the crafting grid, and you'll get 8 shafts. And to craft a gearbox, you have to put 1 andesite casing in the middle, along with 4 cogwheels to the side of that andesite casing, and that will get you a gearbox. Or in the crafting grid, if you place a vertical gearbox, it will turn it to a regular gearbox. And if you want a vertical gearbox, all you have to do is place an andesite casing in the middle and 4 cogwheels on the corners rather than on the sides. Or you can just put a gearbox in the crafting grid and that'll make it vertical. And if you want to make a cogwheel, all you have to do is place a shaft anywhere in the crafting grid along with a plank, and that'll get you a regular cogwheel. And there are two ways to make the large cogwheel, and the first one is just one shaft in the crafting grid and 2 planks anywhere. And that will get you your large cogwheel, but you could also place a cogwheel in the grid and just add 1 oak plank to it to get the large cogwheel as well. So the next way I'm going to show you how to move around your rotational power is called the mechanical belt. So to make a belt, you not only have to have the mechanical belt item, but you also have to have at least 2 shafts in a line, and then if you right click on one shaft with a mechanical belt, then you get these particles as you drag it over to the other one, and if the particles are red, that means you can't place it there, either due to there not being a shaft where you're looking, or there could be a block in between the 2 shafts that you're trying to connect the belt to. But once you get these green particles, that means you can place down the belt, and a belt can only be up to 20 blocks long. There are a few other things you can do with them as well. The first is you can actually extend the belt by right-clicking on it with a mechanical belt in your hand, and this won't actually use the mechanical belt up, you just need to have it in your hand for this to work. And you'll also need to right click on the end of the belt, because if you right click on one of the middle parts, it won't actually extend it. And you can also retract the belt by right clicking on the end of the belt with a wrench. And you have to right click with the wrench on the half that is closest to the end of the belt. So if I were to right click on the right half of this block, it would not retract the belt, but if I click on the left side, it'll retract it. And the same thing happens for the opposite side, where you have to right click on the right side rather than the left. And another thing we can do with belts, as you can see here, is make them vertical. So if you place down a couple of shafts that are vertical from each other, you can connect up a belt just like you would with a horizontal one, except for it's vertical. Which also means that if we were to place a hand crank on this belt, since we have these 2 shafts connected, this belt will not only spin, but so will the other one. And that brings me to my next point, which is that belts, if you power one shaft in the belt, it will power all the other shafts in the belt as well. And another thing you can do with belts is if you have an empty space where there's no shaft, you can actually right click on that space with a shaft, and it'll place down a shaft inside that part of the belt where you just placed it. And you can also pick that shaft back up by right clicking on it with the wrench. You'll also want to be careful not to click on that belt, because if you do that, it will actually split that one belt into multiple. Since a mechanical belt needs 2 shafts to exist, what would happen if you tried to split the belt when there's only 3 shafts? Well, what happens is it actually takes a shaft out of your inventory and places it on the belt that needs it. But if you don't have any shafts in your inventory, instead of splitting the belt, it will just pick that shaft up whenever you right click on it with the wrench. Or if there's no shafts, it'll do nothing. But if you do have shafts in your inventory and you right click on a belt, it'll just split that belt up using the shafts that you have. And let's say you only have 1 shaft in your inventory, but to split this belt, you would need 2 shafts. So if you right click on it with the wrench, nothing will happen unless you have enough shafts to satisfy the need of having 2 shafts per mechanical belt. And the next thing you can do with these belts is actually place vertical shafts like this and connect them up with a mechanical belt. And whenever you break a belt, if you break a part of the belt where there isn't a shaft there, it will just break the belt. And the same thing happens if you use a wrench. But if instead you break this part where the shaft is, it will actually break the shaft along with the belt. And this works even when you're using your hands, even though normally you can't break a belt with your hand and get it back. But something you aren't able to do is turn a belt 90 degrees. As you can see here, we have a vertical shaft trying to connect to a horizontal one, and that just doesn't work. And the last thing I'll show you with mechanical belts is actually that you can make them diagonal. So if we have a shaft here and a shaft here, we can go ahead and connect those up, and that will make the belt diagonal. And it's also important to know that the diagonal belts have to be a perfect 1-to-1 slope. And as you can see, if I try to bring this shaft over 2 blocks but down 1, it just gives me red particles. But if I go over 1 and down 1, I can make it diagonal. And just like with the other types of belts that you can extend and retract using the wrench, you can also do that with diagonal belts as well. And we can see here that if we were to turn this hand crank, all 3 of these belts move since they're all connected together. And even if I were to remove this shaft here, it would still allow the belts to spin. It's also important to know that whichever way you input the rotation is the way that it will output. So we have a hand crank on this belt here, and we're spinning it counterclockwise. That means that the shaft down here is also going to output counterclockwise. And if we were to crouch and right click on the hand crank to make it clockwise, that bottom shaft would also output clockwise. And another way to move power around is using encased chain drives. And basically what these do is if you place one down and you put another in a line, whenever you spin one of these shafts, it will spin all the shafts on the other encased chain drives in the line in the same direction. And you can make this encased chain drive infinitely long. And this is also another one of the blocks that if you crouch and right click with the wrench, you can pick it up. And in addition to being horizontal, they can also be vertical. And unlike the belts, they cannot be diagonal. As you can see, if I put them diagonally like this, nothing happens. And another thing is you can't have the same drive going horizontal and vertical at the same time. You can only have one or the other. And you can also see that whenever an encased chain drive is in the same drive line as another one, this border around it will expand. So we can see that we have that andesite casing look around the edge, but if I place another drive in the line, that will actually get removed, and these textures will connect up with this little black strip. And the thing that makes these encased chain drives so much more useful is the fact that if you right click on one encased chain drive that's in a line with a wrench, it will rotate 90 degrees. And if we were to spin this hand crank, it will still output power to that encased chain drive that's rotated 90 degrees. And if you rotate it back to the original position, that one will spin as well. And this not only works for horizontal drives, but also for vertical ones. And also, if we wanted to connect this encased chain drive to say this encased chain drive, we can flip this middle one vertical while still keeping this one open to say connect to another encased chain drive. And once we spin this, we can see that this drive is spinning because its shaft is connected to the shaft on this encased chain drive and the other line. And we can also see that this top one spins since it has a shaft on the bottom of the block. And in this line, it has a shaft on the top, which connects it up to this top line of encased chain drives. And being able to rotate 90 degrees like this is the only reason, other than that it looks different, that these are used over mechanical belts. And that's because a mechanical belt can do everything an encased chain drive can, as well as go diagonal, except for that the mechanical belt can't rotate 90 degrees like this. And the mechanical belt is also cheaper to make. And to show you how much cheaper, we can see that to make one mechanical belt, all it costs is 6 dried kelp, and that's it. And you only need one mechanical belt that can span 20 blocks. But if you have an encased chain drive, it costs 1 andesite casing as well as 3 either zinc or iron nuggets. Now I'm going to show you how to move your power around using cogwheels. So whenever you place down a cogwheel, you can see that it actually has this shaft sticking through the middle. And you can also rotate them any direction you want, whether it be vertical or horizontal. And then you can just spin it using something like a hand crank, and that cogwheel will spin in the direction the rotation is going in. But you can also connect a cogwheel on the side like this, and you can see that the gears are touching, which means that whenever I spin this one, the other one will also spin. But as you can see, it actually spins in the opposite direction. So I'm making this cogwheel go counterclockwise, but the other one is spinning clockwise. And you can also connect up large cogwheels to small ones, and then you can connect up the large one back to another small one, and you can have them rotate all like this. But it is important to know that you can't place a large cogwheel to the side of a regular cogwheel since they won't connect up. They have to be diagonal from each other. One of the main things that cogwheels are useful for is actually that they can use gear ratios to change the RPM of the input from the output. Since this large cogwheel has more teeth than the small cogwheel, if I were to power this small cogwheel, then the large cogwheel is going to spin at half the speed that the small one is spinning at. But if we do that in reverse, where we spin the large cogwheel, it will actually make the small cogwheel spin twice as fast as the large cogwheel spins. And you can take this to the extreme with this setup, which I'll show you how to do in just a moment. But basically what it does is you hand crank the cogwheel, and then this cogwheel starts spinning, which makes this one go twice the speed, and then this one starts spinning because it's connected to this one, and then that makes this one spin twice the speed, and so on and so forth until it gets to the max RPM possible, which is 256. So if I spin this one, that means that this cogwheel on the end here is going to be spinning at 256 RPM, which is the max. Since this hand crank makes it spin at 32 RPM, which goes into this, which doubles it to this one to make it 64, and this large cogwheel doubles it to this small one, which becomes 128, and that goes into this large cogwheel, which doubles this last one to 256 RPM. But if we were to double this one more time, you'll actually see that that cogwheel just breaks since it's trying to make this one spin so fast. And that's because we have 32 input going here, 64 output, we have 128 output here, 256 output here, and 512 RPM output here, which isn't possible. And the way I do this is by first placing down a large cogwheel with a small one connected to it, and you can actually encase these cogwheels using an andesite casing, and that will make that shaft disappear, but it will still be able to spin from the large cogwheel. So now if we place another small cogwheel on this large one, and then we place a large cogwheel here, this shaft won't connect up to this one, which would actually break this system. And if you want to add the shaft back, you can simply right click on the face where you want it, and if you want to remove the casing entirely, you can crouch right click and that'll pick up the casing. And another neat thing about encasing these cogwheels is that you have to have an andesite casing to do it, but it doesn't actually cost you an andesite casing when placing it. What I mean by that is I can just have one casing and I can encase all 4 of these cogwheels without using it up. The reason we need these casings is because if these two are touching, it will actually break this system from working entirely, and I'll show you what happens. So basically, if I try to spin this one counterclockwise, it will make this one spin clockwise, which will make this one spin clockwise, and this one spin counterclockwise. And that's the correct direction of rotation, but since these are connected, the RPMs will mix together and just create an infinitely fast spinning cogwheel. But since that can't happen, whenever you try to spin it, it just breaks one of the cogwheels. Now this whole contraption here will show you how to use quite a few different items. The first is the gear shift. So what this does is it has 2 shafts, and whenever I give one of them power, it will spin the belt the same direction that the hand crank is spinning. But if I give this a redstone signal, it will light up on the side, and it'll make the output spin in the opposite direction from the input. And the next thing I'm going to show you is this clutch. Whenever you give it rotational power like normal, it will just send it through without changing it at all. But if you give it a redstone signal, it will not output power at all. And if we combine these two, and we spin the belt, we'll be able to see that we spin the belt counterclockwise while the gear shift outputs it clockwise and the clutch outputs nothing. And if we were to turn them off, it would allow the clutch to spin as well as the gear shift. And another useful thing that I'm going to show you here is called the redstone link. So what this does is you can give it a frequency using two different items in these two little slots, and those can be any items you want, except for something like the wrench, since right-clicking on it with the wrench does something else. And then if you go to another redstone link and you give it that same frequency and you right-click on it with a wrench, that will give it this little disc here, which tells you that the link is in receiver mode. And we can do the same thing on the other side, but give it a different frequency, and I'll show you what the different frequency does. So now, whenever I power this redstone link, all the other redstone links are going to be searching for that same signal, which means that whenever I power this one on, this redstone link will wirelessly get powered as well. And if you try to power it from the receiver, you just can't. So you can only power it from the link that is not set to receiver. And if this isn't a receiver, it won't actually receive the frequency and it won't power anything. And we can see over here that this one is not on because it doesn't have the same frequency. But if I were to give it the same frequency, you'll see that it turns on. And if I power this redstone link off, it'll power off the other ones wirelessly. And you can have as many redstone links with the same frequency as you want. There is no limit. And the last thing I'm going to show you over here is the fact that these mechanical belts can actually transport items. And what happens is whenever you drop any item on the belt, it will pick it up and set it on the belt. And if you try to add another of the same item, it won't go on the belt. And you can also right click on the belt with an empty hand to get that item off the belt. And if you want to move stacks of items at a time, you have to throw the entire stack on the belt at once. Otherwise, they just won't stack and this will sit on top of the belt until this other item moves out of the way. And we can also place another item on the end of the belt. And now what happens is whenever we spin this, that log moves down to the end. But since there's a full block in the end of this belt, that means that this item is not allowed to drop off the belt. And that allows this item to keep going while the other one stays still until they go up against each other. And now they're just stuck until either this block gets moved or they get moved in a different direction on the belt. But if we were to give it the opposite direction of rotation, the belt would spin the other way, which would allow our items to go in the other direction. And since there's no full block on the end of this, the items will just fall off the end of the belt whenever they get to it. And the faster this belt spins, the faster the item will fly off and the further they'll go. And not only can you have a belt move items horizontally, but you're also able to move items on a diagonal belt as well. And you can do it in both directions. However, you aren't able to move items across a vertical belt or a belt that's sideways like this. This video is getting a bit long, so I'm going to cut it off here, but you can leave a comment down below if you want to see part 2 where I teach you how to use the Create Mod machines, and I would really appreciate it if you hit that like and subscribe button, turn on notifications. Thank you so much for watching, and I'll see you in the next one.